All right, welcome to Unit 3. We are going to learn about elementary probability theory. Our first lesson is going to have an objective of finding the probabilities of simple events. Probability is a numerical measurement of the likelihood of an event. And the probability of an event is a number between 0 and 1. A probability of 0 means that the event will not occur, it cannot occur. And the probability of 1 means that the event has to occur. There's a 100% chance it will occur. So probabilities closer to 1 are more likely to occur, and probabilities closer to 0 are less likely to occur. So if we want to say the probability of event A, we use a capital P with parentheses and then a capital A. And so, as I was saying, if the probability of event A is 1, A has to occur, it's certain. And if the probability of an event is 0, then that event cannot occur. It's an impossibility. There are 3 basic methods people use to find probabilities. One is intuition, the other is experimental, and then the final is theoretical. Intuition tends to not be very reliable. It incorporates past experience, judgment, or opinion. It's based upon the level of confidence in the result. Okay, so when people say, I'm 95% sure I will attend that party, that means that they have intuition that tells them that. Okay, we will spend a lot of time in our class doing experimental probability and theoretical probability. Experimental probability is determined by actually conducting an experiment, seeing the activity take place over a number of times, and it's the fraction of the time that the event you're interested in occurred over the total number of times an event happened. Not necessarily the event you were interested in, but the event that could be divided up into, what I wanted happened, what I wanted didn't happen. So it's the sample size, more or less. So if you note that 57 of the last 100 applicants for a job have been female, the probability that the next applicant is female would be 57 over 100 based on the results you've seen so far. Theoretical probability is probability that we get from formulas. Okay, in theory, this is what should happen. And all the theoretical probabilities are backed up by experimental probabilities done thousands of times. An example would be like equally likely outcomes, determining the probability of that. So when outcomes of simple events are equally likely, then the probability of those simple events or an event comprised of several simple events is just the probability of the event equals the number of outcomes favorable to the event and the total number of outcomes. Consider rolling a standard die. Find the probability of getting a number less than 3. So that means getting 1 or 2. So if the favorable events are getting a 1 or a 2, and there's 2 of those, so that's our numerator, over the total number of outcomes, there's 6 of those, 1, 2, 3, 4, 5, 6. And that reduces to 1/3. Okay, so like I said, the bridge between experimental probability and theoretical probability is repeating the experiment over and over and over, thousands of times. So this is called the law of large numbers. In the long run, as the sample size increases and increases, the relative frequencies of outcomes get closer and closer to the theoretical or actual probability value. Okay, we've got to get some definitions down before we can look at more problems. Statistical experiment or statistical observation is any random activity in terms of probability studies that results in a definite outcome. An event is a collection of one or more outcomes of a statistical experiment or observation. A simple event is an outcome of a statistical experiment that consists of one and only one of those outcomes. A sample space is the set of all possible distinct outcomes of an experiment. The sum of all probabilities of all simple experiments in a sample space must equal 1. Okay, because one of them has to happen. Their total probability has to be 1, which is saying that, okay, one of these outcomes has to happen 100% of the time. Okay, you're going to get one of them. Can't tell you which one, but it's going to be one of these every time. So the sample space for rolling a standard ordinary die would be 1, 2, 3, 4, 5, 6. That set of numbers. Let's consider rolling an ordinary die. The probability of getting an even number would be 3 out of 6, because there's 3 even numbers, 2, 4, 6 out of the 6 possible outcomes, and that would reduce to 1/2. You don't have to reduce, but if you do reduce, you need to make sure you do it correctly. The probability that the result is less than 5, so 1, 2, 3, 4, there's 4 of those out of the 6 outcomes, and so it's equivalent to 2/3. The probability of not getting a 2 means 5 out of 6, because you could get a 1, a 3, 4, 5, or 6. A complement of an event is the event that it does not occur. Okay, so here's a Venn diagram. If what's represented in the blue circle is event A, everything else on the outside of it, all of this pink area, is a complement. So the event that A does not occur, the probability of A complement is 1 minus the probability of A. So when you add the probability of A plus the probability of A complement, you get the probability of the whole sample space, and so it's 1. If the probability that it will rain today is 30%, the probability it will not rain is 1 minus the probability of rain. So 1 minus 0.3, so 0.7. Okay, a lot of times people think probability and odds are exactly the same thing. They are related, but they're different. And the difference is in the denominator. The odds in favor of an event is the reduced ratio of favorable outcomes to unfavorable ones. So probabilities, the ratio of favorable outcomes to all outcomes. Odds are the ratio of favorable outcomes to unfavorable ones. The odds against an event is the reduced ratio of unfavorable events to favorable. The probability of an event is the reduced ratio of favorable outcomes to the total number, favorable plus unfavorable outcomes. So consider rolling a die. What are the odds in favor of rolling a 2? Okay, so we look at our sample space. There's one way to get a 2. There's 5 ways to not get a 2. So it's 1 to 5. Now, remember, the probability of rolling a 2 is 1 out of 6. All right, that's because for probability, that 6 comes from the total number of outcomes. The 5 for the odds is the total number of ways to not get a 2. What are the odds against rolling a 2? They're going to be 5 to 1. We don't ever reduce that down to a whole number. We write it as 5 over 1. So again, probability is different. So when we look at our sample space and we want the probability of rolling a 2, we note that there's one way to get a 2 out of 6 total outcomes. Probability makes statements about what will occur when samples are drawn from a known population. Statistics describe how samples are to be obtained and how inferences are to be made about unknown populations. So that's kind of the relationship between the two. All right, so go ahead. You're going to do a problem to try on your own. You've got a single spin of a fair spinner. That means each of the outcomes is equally likely. There's 8 sections, and you're going to find a couple of probabilities, and then you're going to find some odds. All right, guys, if you have any questions, please email me or drop by my classroom. I'm always here to help you. Thank you for watching the video. I hope you have a great day.